Activity 6 is Exponent Experts Part 1 from Unit 1 Recap in Number Sense. So we're going to begin with looking at multiplying powers. A power is a way of representing a repeated multiplication. So multiplication represents repeated addition, and a power represents repeated multiplication. So a power is something that has a base, the large number, which is the number that is multiplying, and an exponent, the small superscript number to the right, and it represents how many times it's being multiplied. So if I look at a product, which is another way of saying multiplication of powers, 10 to the 2 times 10 to the 3, a power times a power really means 10 times 10, 2 tens, times 10 times 10 times 10, which is 3 tens. So in fact, we get a repeated multiplication. 10 times 10 times 10 times 10 times 10. Because we have a repeated multiplication with the same number, our base is 10, and we have 2 of them here and 3 of them there, so it's 10 to the 2 plus 3, or 10 multiplied 5 times. Similarly, if I have 10 to the 4th, which is a power, times 10 to the 5th, another power, 4 tens times 5 tens is the same as writing it as a repeated multiplication as 10 to the 4 plus 5, so it's the same as having 10 9 times. 5 to the 3rd times 5 to the 2, or 5 squared, 3 5s multiplied with 2 5s gives me 5 5s. I add the 3 and the 2 together. And lastly, 3 to the 5th times 3 to the 6th, I'd have 5 3s multiplied with 6 3s, so I'd have to add the 5 and the 6 together to get a total of 11 3s. So it's the same as 3 to the 11th. So we can summarize this in a rule for multiplying powers. So if you are multiplying powers with the same base, 10 and 10, 10 and 10, 5 and 5, 3 and 3. So it's an important thing to notice if your bases are the same. And if they are the same, keep it the same and simply add the exponents. So in general, we say a to the n times a to the m is the same as a to the n plus m. The two exponents are added together and the base remains the same. And we like to use a here to keep it general. It doesn't matter what number it is. So looking at some examples, if I have 2 to the 3rd times 2 to the 4th, same base, 2, keep it the same, add the exponents, 3 plus 4. It would look like this if I wrote it out, 3 2's followed by 4 2's, which gives me 2 to the exponent 7 as my answer. X to the 3 times x to the 3. So here I have a variable for my base, or a letter instead of a number, but all that matters is that the bases are the same. So I keep the base the same, x, and I'm going to add my two exponents, 3 plus 3. In expanded form, it would look like this, 3x's followed by 3x's in a repeated multiplication, which is 6x's in a repeated multiplication, or x to the 6th, 3 plus 3. X times x squared looks a little strange because this first one, x, doesn't necessarily look like a power, but it really is. How many x's are in this multiplication here? One of them. So when you have a power and the exponent is not there, it is automatically assumed to be a 1 because you have one of those bases. So in expanded form, there would be my x, or x to the 1. There's my x to the 2, or 2x's. Adding 1 and 2 together, keep the base the same at x, gives me 3 as the exponent. And lastly, I can also have numbers along with the powers. So in this case, I have 2x squared times 5x cubed. Now the 2 and the 5 are not part of the power with the exponent. This exponent 2 only goes with the x because that is what it is immediately after. So I can multiply the numbers together to get 10, and then I'm going to add the exponents. And in expanded form, we would see that this is 2 times 5, x times x, x times x times x, So I have 2 times 5 to give me 10. Add the exponents together, 2 and 3, and I had a total of 5 x's. So the answer is 10x to the 5th.